I'm going to jump right in. Again, for questions, you guys just go ahead and ask them in the Q&A, and we'll get to them at the end. All right, so today we're going to be talking about the current state of machine learning and AI. I've been collecting some really cool stuff happening in the domain, and it's really exciting for me to get to show it off to you guys. So a little bit of housekeeping first, a few things I want to touch on. You probably are curious who I am. A number of you already know me. So my studies were mainly in physics simulation. Because of that, I got a pretty good foundation in computer stuff. In the last year of my studies, I was lucky. I got more and more to play with machine learning things. And then when I finished my studies in 2018, that led me very quickly to a job with this great company called Data Insights, who have provided me a wonderful atmosphere to sort of work on some different machine learning applications and really do some fun stuff in the domain. So I'm still fairly new. I've been doing machine learning, I guess, full-time for about 2 years now. So all that's to say that I am a very small fish in a big ocean, which is machine learning and AI. I can't stress enough how quickly and lightning fast this domain is moving. And it's really impossible to keep up with everything. To sort of stress that point, one of the biggest conferences in machine learning is the International Conference for Learning Representation in London. And last year there was 1,449 submitted papers and 500 accepted. So trying to keep up with everything is a futile task. And also because I'm definitely not sort of the king of machine learning, I promise there will be bits in this talk that will be either outdated or perhaps flat out wrong. So if there are people here who are machine learning experts, which I hope there will be some, that would be awesome. At the end of the talk, definitely send me a message, or even in the middle, you can send a message in the Q&A and say, oh, actually, this is a little different now. So I would really appreciate that. The next thing I want to talk about is sort of, I'm doing something here which is a little crazy. I'm trying to pack 4 different interests into one talk, which is usually a pretty audacious idea. So I want to summarize what you might get out of this. If you don't have any interest in actually doing machine learning and AI, that's absolutely fine. I've tried to include sections that will give you a really rough idea of what's happening and sort of what it means for the future of humanity. If you're new to ML and you're trying to sort of get more into it, perhaps as a profession, this will hopefully be a good way to really grok what is happening in the domain. And another thing is at the end, I'm going to be including a section where we give tips about sort of what you can do to get into it and really what helps. If you're a business person and you're here to find out how to make the most money, that's also excellent. A big question when companies come to us is what can we do with ML? Sort of we hear about this thing and what is it actually used for? We're going to try and answer what's possible these days. And another thing is we're going to try and speed up sort of this academia to industry delay, which is usually a few years when these really cool new technologies are showcased at these academic conferences. There's definitely a lag to get them into industry. So hopefully you'll jump on some of the ones you see here and maybe try and push them forward in your business. And of course, if you're a machine learning expert, that's awesome too. Hopefully you'll still learn something new, or if nothing else, I'm hoping that maybe this will validate what you know. One last little formality before we really start is I want to give you some terminology. So there's 3 words that people bounce around a lot. They are machine learning, artificial intelligence, and deep learning. Everyone also has slightly different definitions of these. The one I usually go by is I define machine learning as any instance in which basically a machine just learns to do things better and better. I think the simplest example of this, most people would agree, is curve fitting. It's also called regression. So this is super simple. It's just a machine trying to sort of fit a curve through some dots and getting better at it. I think most people would say that's sort of the most basic machine learning. Artificial intelligence is a little more nuanced. I would define it, again, this is my personal one, as anytime you're trying to get a computer to do something that is usually reserved more for people or historically was thought to be sort of a people-only task. Perhaps one of the simplest forms of AI is character recognition. It's a fairly old machine learning technology in which these neural networks are able to say, hey, that's a 5, that's a 0, that's a 4, blah, blah, blah. In addition, this is a good example of an overlap between machine learning and AI, where you are using machine learning techniques. Then there's this region over here. This is sort of the beware this region. I've put it there because a lot of companies also have artificial intelligence solutions proposed which don't make use of machine learning. They can sometimes fit your use cases, but they're also definitely used more as sort of sales points. I have this great picture here which sort of illustrates the issue when you look under and it's actually just if the customer says this in a chatbot, then answer with this answer. So it's a little disingenuous. There's nothing wrong with it per se, but just beware when companies tout these very fancy AI solutions, which are just if-else loops. And then there's this sort of subset called deep learning. Deep learning is definitely a bit of a buzzword. It's generally when people are just using these deep neural networks. Also, how to define that is a little bit nuanced. I would say a good one is 50 plus layers in your neural network. Other people might say maybe 10 plus. It really depends who you talk to. And you can actually have deep learning, which is not AI, although it's not too common. An example could be perhaps curve fitting if you're using a deep artificial neural network. But anyway, so hopefully this gives you guys an idea of what these words are, especially for business people. You hear them a lot in the industry. So I'm going to go over the game plan. I'm going to try and first touch on hardware developments. This is sort of where some of the biggest stuff has happened recently. After that, NLP is natural language processing, a huge domain and moving really fast. GANs are these generative adversarial networks that are just really cool. Computer vision, AGI, I'm going to go over these. AGI is artificial general intelligence. These two I'll go a little faster on because I don't have as much to say. And then we'll give some tips for everyone, for business people, just some summaries of what you should learn for people trying to get in business. And lastly, closing remarks. I'm also going to take 1 second and just drink some water because I need a little water before I start. Important to stay hydrated. Alright, so let's get going. So I started with hardware developments because, in my opinion, one of the biggest game changers in machine learning and AI right now is this tensor processing unit. What this is in addition to GPUs and CPUs, some very smart people over the past few years have realized, well, machine learning is basically just these big tensor multiplications. And if you don't know what a tensor is, think of a big matrix. And if that's a little uncomfortable, just a lot of numbers getting multiplied. In around 2016, it was actually a little before that where these first started getting rolling. People were saying, well, why don't we just make hardware that's optimized for these multiplications? So this has happened. It was introduced in 2016 by Google, and then third parties were able to access it at around 2018. It was also confirmed later that AlphaGo, which was the Go-playing robot that defeated Lee Sedol in 2016, did use this technology. NVIDIA also launched their Tensor Core, so also sort of the same thing. They look really snazzy, like kind of a sci-fi movie kind of thing. This is amazing in and of itself, but the really big game changer is actually something even more recent, which is called edge TPUs. So these are very small tensor processing units, and they will really revolutionize things in a lot of ways. I'll explain that in a second. Right now, there's Google Coral, that's the one on the right. NVIDIA Jetson Nano is the bottom left, and in the middle there's also Intel Neural Compute Stick, which is somewhat different, but serves basically the same function. These are costing about 150 euros, so they're not sort of out of sight expensive, and you can do all sorts of cool AI applications on them. In fact, they've already been implemented into things. The Google Pixel 4 has an edge TPU in it, and some Asus computers are now coming with them, and there are probably others here too. So why is this a big deal? Why will this change things? They're just these little sort of AI Arduinos. Why will this be a big deal? To understand this, the first thing you need to understand is that there's going to be a big shift in where data is stored in the next few years. This is out of the EU AI white paper. Specifically, the source is listed here, and it's saying that although right now 80% of data is in these data centers, by 2025, so quite soon, 80% is going to be on edge locations. That could be sort of people's phones, factories, hospitals, blah, blah, blah. And this seems like a crazy statement to make. And I'm sure there are a lot of people right now listening who are thinking this is nuts. The question should be, why? Why would we do this? We just spent years going from databases to cloud. What's sort of the motivation to go vice versa? It's a pretty big claim. I've drawn some very high-tech images to help you understand the situation. You can see this is sort of top. This is almost as good as Madeline's last week, but I can't compete there. This is sort of how the setup usually works these days. The idea is people, edge users, they have their edge devices. The data gets sent to the cloud. The training happens on everyone's data in the cloud, and then these models get pushed back. This is sort of, the standard model. The pro to this, one of the biggest pros is definitely you can train on sort of these huge data sets. But there's some cons. One of the cons is it's difficult to really get models personalized for each of your edge users because you keep having to push them back and get the data, push it back. Another thing is you have to update them often to really keep up with what your users are doing. And a big con is good network strength is also required. You really need to make sure your users have access to data or Wi-Fi or some connection. And one of the biggest cons, which has become bigger sort of with the implementation of GDPR, is this leads to really big privacy issues. Even outside of Europe, a lot of models are more and more sort of coming down on this model just because it doesn't really fit in the data privacy standards. There's a quote I have from a machine learning conference I was at last year. One of the speakers said 80% of startups, they flat out propose something illegal because they don't understand how this works. And they just come in and say, we're going to take the user data, we're going to train it on the cloud, and blah, blah, blah. And then, nope, you can't do that because GDPR just won't let you. So there's sort of this new model coming up now. The new idea, especially made possible with these edge TPUs, is you actually just push an untrained model or a semi-trained model onto someone's phone or edge device or whatever, and you have it constantly training as they do their thing. There's some big pros here. First of all, it can quickly personalize. They're always updating as the person is doing their thing. Because of edge TPUs, this is becoming more viable because edge TPUs not only train neural networks more efficiently, but they also do it more energy efficiently, meaning you're not going to kill your phone battery, kill your phone's battery if you're sort of training some networks in the background. These also don't need to be connected to the web. The training can keep going on. There are definitely cons here. So the biggest con is you lose that huge corpus of data. This has huge implications. It means that probably you're going to need to get some either sample data from a group of people who agree to have their data used, or you might have to have synthetic training data. We'll come back to how you can do this later. But there's one huge pro, which is you get around most of these privacy considerations. To give you an example of that came out of the same machine learning workshop I mentioned last time, you cannot just take people's location and tracking data, how they're moving around the city, and just put it into some big database to be trained on in the cloud. This is a big no-no under GDPR. But you are allowed to train on users' motion data if it stays within the phone. I'm not a GDPR expert. I'm quoting what has been told to me at one of these machine learning fairs. However, this is the general idea, that a lot of these implementations of interesting use cases can be done if you're going to do it locally on the edge device. Another big consequence of these edge TPUs is for sort of developing world applications. Take a hospital, for example, where it's just not feasible to have sort of a constantly updating connection to some big cloud provider. You can now just get a pre-trained ML model, perhaps from another hospital, if you can get around privacy considerations, otherwise just an untrained one, and you just train locally on their own patient data. You won't run into security issues through this. You don't have to worry about the network being disconnected from Wi-Fi as long as someone is just putting in the necessary data into the computer. And there's low power requirements, great for a country where you might have frequent power failures and you just need to operate on a generator or something. So this is a big game changer. And one word of advice for people in business right now, you need to adapt to this new reality of ML on the edge. It may not happen in the next 5 years, but it's definitely coming. There's going to be more and more models training on edge devices. And when you're thinking of which use cases to implement, definitely take this into consideration. That's everything I want to say about this. I'm going to move to natural language processing now, because NLP is just crazy right now. For those who don't know NLP, the idea here is just you're going to try and write like a human does. That's all there is to it. So I said it's going crazy, and it really is. It's going absolutely crazy. You usually measure the complexity of a machine learning model by the number of parameters it has. Some of the most recent ones, so this is just January 2020, you see on the right-hand side, you're talking 17 billion parameters. And if you're not sort of up to date about how many is a lot, take my word, that is a lot of parameters. Models and also data corpuses are both getting just massive. They're getting just unimaginably big. And companies are just pumping money into this because it just so happens that this is a case where more money and more parameters just does work better. I would say we're more or less there at the point where these NLP models cannot be distinguished from humans for almost all language tasks. To give you an idea of sort of what this entails, I found this great quote from an article on NLP. So the idea is, the question is just how much does it cost to train a model? Two correct answers are depends and a lot. These are some sort of very ballpark figures for how expensive it is to train one of these now. If you're talking 110 million parameters, each time you do a training run, that sort of run through your data one time, you're looking at $2,500 US dollars. If you're trying to train a really big one, like 1.5 billion parameters, the estimated cost is about 80,000 per run. Another thing to consider is you can't just run your model once and expect it to work. You probably need, I estimate, about 20 runs because you have to sort of tune what are called hyperparameters. These are sort of how your model trains. If you're doing 1.5 billion parameters 20 times, you're looking at about 1.6 million US dollars to train this model up to performant quality. Data size is also getting huge. We're talking about the biggest data set is the C4 one. It's got 35 billion words pulled out of like almost all the websites available, plus books have been scanned to try and get it. And yeah, this is just getting big really fast. So there's some bad sides and good sides. The bad side is state-of-the-art NLP is now really only achievable by the big players. These little startups have difficulty sort of competing in this. Another thing is the models, the trained models, are almost always kept a secret, and we'll discuss why in a little bit. The good side is when companies realize putting money into things makes them better, and better means more money, they tend to keep doing it, and the cycle means really good NLP. So I would say this is probably one of the fastest moving domains right now. I want to give you an idea of sort of where we're at. This is a huge wall of text, but I'd like to read about half of it to you, or maybe a third, and just think it over, okay? So, in a shocking finding, scientists discovered a herd of unicorns living in a remote, previously unexplored valley in the Andes Mountains. Even more surprising to the researchers was the fact that the unicorns spoke perfect English. The scientists named the population after their distinctive horn, Ovid's unicorn. Dr. Jorge Perez, an evolutionary biologist from the University of La Paz, and several companions were exploring the Andes Mountains when they found a small valley with no other animals or humans. Perez noticed that the valley had what appeared to be a natural fountain, surrounded by 2 peaks of rock and silver snow. Perez and the others then ventured further into the valley. By the time we reached the top of one peak, the water looked blue, with some crystals on top, said Perez. So I'll stop there. It's quite long, so I won't read the whole thing. The reason this is impressive is because only these 2 sentences were provided to the machine learning model. Just these 2. Everything else here was written by a model that knew nothing previously except what it had studied on the internet. Dr. Jorge Perez was made up by the machine. His quote was made up by the machine. Ovid's unicorn as the name of the species was made up by the machine. This is pretty just flabbergasting, really. This is quite amazing as a show of how far we've come. This model is GPT-2. The paper about it I put on the bottom. It's one of them being pushed by a group called OpenAI. The reason why this is a little dangerous is because you can give it any prompt you want. For example, if you say recycling is not actually good for the world as your first prompt, the model will create a very, very believable article, and it'll even sort of try and draw sources about why recycling is not actually good for the world. You can also say, for today's homework assignment, please describe the reasons for the US Civil War, and this model will write you a homework assignment. It even quotes people from Wikipedia articles on the US Civil War automatically and fits them in places where it makes sense to have them quoted. You can sort of attack celebrities and say Miley Cyrus was caught shoplifting from Abercrombie & Fitch on Hollywood Boulevard today, and it'll make a sensationalist article about how that's true. And you can get it to write fanfics. You can say Legolas and Gimli put down their weapons and look deep into each other's eyes. This is why the model hasn't been released to the public yet, and the big ones generally aren't. There's a huge, huge amount of potential for malicious use here, and I think we don't have the answer on how best to sort of mitigate it. There's just so many people on the web that aren't aware that we have the capabilities of doing this and would just believe what they're reading. And I don't have the answer either, so this is something to think about. NLP is also getting really good at conversation. Sorry for the bad quality of this. This was actually presented just a month ago at a NVIDIA webinar, and I actually just screenshotted it because I was so impressed. If you want the paper, it's on the top right there. And this model is called Megatron LM. It has 8 billion parameters, and it was just trained on huge amounts of Reddit data. So the starting prompt, this is a human writing this, just said, who do you think will win the 2020 election? And the answer comes from the robot, probably Harris. So the scientist replies, okay, why do you think Harris over the other candidates? The bot replies, she seems more appealing to me. The scientist says, well, what about her is appealing? I don't think she's doing too well in the polls compared to Bernie or Warren. So now the bot replies, she has a strong history as a prosecutor and appeals to many people. She's young and has a great resume, very responsive to challenges, etc. She also seems to favor actionable issues as well. Why would I vote for her over other candidates? She's obviously better at choosing party affiliation than personality. The human replies, fair enough. I guess we'll see how things pan out in the primaries. And the robot replies, hoping to be pleasantly surprised with a smiley face. Again, this is just, for me, I would have no notion that this could possibly be a robot. But it's at the point now it's really indistinguishable. You could train it on any corpus you want, and it really learns to talk like humans do. I'd like to talk a little bit about sort of the technology behind these developments. For people who aren't as technical, don't worry, I'm going to go nice and slow. It's just a couple slides, and we're going to get through it together. So for a long time, for the past decade at least, NLP has really been run by what are called residual neural networks. These are networks that are composed of a series of nodes in which each node will take in sort of some information from the previous words in the sentence. And also down here, this little X sort of represents a word being put in. Inside, you can see there's lots of technical stuff and lots of mathematical functions being applied, and it spits out what the next word should be. And then it takes in the next word, and then does some math inside, and spits out the next word. Because it's receiving information from the previous nodes, it sort of keeps a bit of a residue from what the first part of the sentence said. These work great. The one I'm showing you here is called LSTM. It stands for Long Short-Term Memory. It was defined quite a while ago, but has only been applied to NLP for about a decade. It's probably the most well-known, so I'm sort of showing it here. But then we realized quite recently that this one, it doesn't really work as well as they could. There's a few downsides to this model. One is that RNN architectures, all the cool tensor processing unit stuff I showed beforehand, these RNNs don't work super well with these hardware advances. A second reason why they don't really work as well as they could is because they're difficult to parallelize, meaning the work is difficult to split onto different processing units. And the last one is it's been shown that they tend to forget things. So when you're writing a whole article, for example, about, let's say, unicorns, these RNNs, they tend to forget a bit what was said in the beginning of the article. The old way to do it, so this is actually supposed to be the same image as the last slide, it's just sort of done with these squares which represent vectors. You see, the old way was you had a sentence like, the cat sat on the mat, it was a bad cat. So you start with the purple model, which is sort of on the bottom left here. You add the word the as a vector. Then you change it a bit, cat, change it a bit, changing meaning like updating, doing those functions, sat on the mat. And when you get to the end, it pops out, okay, best choice is probably, it was a bad cat. It turns out just a better way to do this, surprisingly, is you just put them all in. You don't really even care about this residue stuff. You just pump them in. So you have the cats on the mat is a bad, you just put that whole thing in, and you just pop out cat. This is called transformers. That's actually the reason why that model presented by NVIDIA is called Megatron. It's kind of a bad joke, but it's kind of cute too. Here's the article that introduced them on the bottom right there if you want to check them out. And when your sentence gets longer, you just put in more things. So the cat sat on the mat gets put in, you get it. The cat sat on the mat, it, you get was. The cat sat on the mat, it was, you get a. And it just works well. The examples I showed you here with the unicorns and also with the political debate, those both were done using transformers. So I think we're really moving away from these RNNs now. So I want to sort of finally summarize where NLPs are before we work our way to the next topic. So for business people, you should expect that customer service chatbots are going to very quickly be indistinguishable from humans, which is probably a good thing for your customer service departments. In addition, we're at the point now where we're more or less out of training data in English. This isn't really a problem because our models are already getting so good. It's not like we have too much further to go. But that being said, we've done like huge book scannings, and also like Wikipedia is used as training data, like every article in English, and it's just at the point we don't really know how to get more. This isn't so true for other languages. Human level speech is a very different thing. That involves different technologies that, to be honest, I'm not too familiar with, so I won't comment too much here, except the fact that NLP is almost perfect at synthesizing text and conversation doesn't necessarily mean we're around the corner from having realistic speech. That's something else, and I'm not too sure about where we're at with that, to be honest. Another cool thing is Microsoft is now preparing for a 100 billion parameter model, which is just nuts. It's called Deep Speed with Zero. And just as a fun fact, the very lower limit on human brain parameters is roughly 100 trillion. This is very rough. It's probably quite a bit more, but that gives an idea of the scale. We're about a factor of 1,000 away from that lower limit on brain complexity. So that's pretty wild. And we're going to talk more about why that doesn't mean we're a factor of 1,000 away from getting human level sort of conscience, but we're getting pretty close. Okay, so with that said, the next thing I want to talk about are generative adversarial networks. So these are called GANs. This is another technology within machine learning and AI where you're trying to just make realistic looking stuff. And I'll talk more about what that means soon. So these GANs were proposed only about 6 years ago. It's kind of a quirky idea. You have these two, you have a bunch of real images. You also have a generator. The generator is going to try and make realistic looking images. Then you have a discriminator, and the discriminator is sort of going to say, okay, this one is real, this one's not. Okay, well, this time this one's real and this one's not. The generator and the discriminator try and compete against each other. So basically the generator tries and tries and tries to figure out ways to fool the discriminator into thinking the images it's sending, they're real. And eventually it gets to the point where the images start looking super real. We're just able to make really realistic fake images. This can also be done with video and other things too. You can use it even for documents and text if you want. When it started, it was kind of this kind of cool thing that people thought, oh, that's kind of neat, you know. One of the first things it could do are these style transfers. So you take an image, you take a painting, and you kind of combine it and get it to learn to make the image look like the painting, in this case Van Gogh. Pretty cool, but again, not really evident there's a real use here for industry. And in fact, just at the conference last year, someone was overheard saying, I can't wait for all this GAN thing to blow over. So it was kind of viewed, I think, as just this passing cloud or something, this fad. But I think we're realizing now that there's more to GANs than that. One thing we realized is GANs can really do everything. One of the craziest things is they can make extremely human-like faces. The one on the left, this person does not actually exist. It's actually from a website called thispersondoesnotexist.com, and you can go and keep refreshing, and you just get super, super realistic-looking people in HD. You can sort of see how GANs have progressed. This is out of an article that was just published actually like 3-4 days ago. And you see just how over the years we're getting just better and better at this. GANs can do all sorts of other creepy things. You can do deep fakes, which most people probably know about. It's basically fake video. There was a very interesting use recently where an Indian politician, India has a lot of languages from one state to the next, so he got local speakers to give the same speech, and then he used deepfakes to project his own face onto all of the speakers, and then all of the people in the states said, wow, this guy's amazing, he speaks like every language. And yeah, it was a tactic to get more votes. So again, it's a bit amazing, but also sort of a bit discomforting. I would urge everyone to remember that even though in 1896 it was said that the camera doesn't lie, GANs probably tell us that the camera should always be assumed to be lying. These deepfakes, they're now indistinguishable from real video. GANs also do other things. Google uses the same technology to turn satellite maps into sort of the maps we see when we choose map mode on Google Maps. Another interesting thing about GANs is you can always flip them, meaning you can always just invert them and go the other way. For example, if you take this sort of fictitious city just drawn in MS Paint or whatever, the GANs will actually pump out a real city, or it tries to make it look like a satellite image. This can be taken in so many directions. For example, on the left we have a GANs that was taught to turn these sort of sketches of cats into real cats. Also, this one turns products into real-looking products from sketches. And the one on the top right, you have an instance where a face sketch gets turned into a sketch of a sort of more realistic-looking person. You can also use it to colorize photos. This GAN has learned that the most sort of realistic-looking photos have blue water, green trees, and green sky. Blue water, green trees, and blue skies. So it's able to colorize old photos. I'd also like to show you this one, which is pretty cool. This was a GAN where it was taught to take a painting and turn it realistic, so to sort of like an actual photo. For me, this is quite humbling because you're able to see what Monet would have seen when he was painting these back in, I think it was the 1800s. So quite humbling that you can sort of go back in time and see the world from his point of view beyond the canvas. Another really, really amazing one is that GANs can restore old video. This entails not only doing colorization, but also increasing the resolution. And quite recently, they're now able to also boost frame rate. So I'm going to pull up an example of that. I have one loaded up on YouTube. This one is quite recent. It just came out last month. What you're looking at here is Paris in the 1890s. So I'm just going to go ahead and play that and just take a look at what it looks like now. Okay, so depending kind of on how good your frame rate was, I hope you're able to appreciate that. If you're not, because you're not experiencing excellent frame rate, definitely go back and watch it. It's really, really seamless and really, really beautiful and kind of surreal to see that you're looking at Paris exactly as if you're really on a street corner in the, oh sorry, I think I said 1980s before, I meant 1890s. That's a little more impressive, 130 years ago. Okay, so moving on. I would like to also just finish with my all-time favorite GAN application. So I have to pull this up again. My very favorite GAN application is this one, which was taught to turn horses into zebras. So someone has actually trained a GAN to turn horses into zebras, and it can also be used naturally to turn zebras into horses in real time. So amazing what we can do these days. So as a summary here, why are GANs fabulous? Why are they amazing, and why are they being included here as sort of my second most amazing thing in the ML AI domain? So first of all, they allow us to do all sorts of cool things, and we've definitely nowhere near explored all the interesting things we can do with them. Secondly, they're really easy to use, and you can actually train them on your laptop. You don't even need a cloud. You can really get them going locally if you have a good enough computer. I'm actually going to show you how to do it in one more slide, but I'm just going to finish with the last point. I talked before about how data is rapidly moving to edge locations, and with that being said, we're going to need more synthetic data. We're going to need to have ways to make up fake data to train them before they're deployed, and this is where GANs can really come in and make a difference. So just in case you want to know how to do this yourself, and I encourage anyone to try, it's really not too technical. First of all, you download the code from this GitHub. After that, you decide what pictures you want to train on. You can put the sort of pictures where it tries to match one picture to a different picture, sort of like the Google Maps data. Or you can also get it to sort of train generally and just understand like zebras have stripes, horses don't. You put them in the folders. You have to do a few updates. You have to update your NVIDIA GPU drivers, your CUDA drivers, and also install PyTorch. And then you run 3 commands. The first command gets this Wisdom server started. This kind of monitors your progress. Then you run this train command, and then you run your test command. And that's it. It's very simple. For me, I've used it on about 100 images. It only took about, I think, 2 hours to train on my laptop. No cloud necessary. So really, go give it a try. There's also a good walkthrough at the bottom if you want to sort of be held step by step. Okay, so that's everything I want to say about GANs. The next thing I'm going to touch on is computer vision. I'm not going to have quite as much to say about computer vision, but I still have a few interesting things just to summarize for everyone. So computer vision underwent this huge sort of deep CNN revolution, which began in about 2012. It was specifically this neural network called AlexNet. And what AlexNet did differently is it was very deep. Most neural networks at the time included maybe 10 layers. AlexNet, I believe, went down to 50. It may have been more, but I think it was about 50. No one had really gone this deep before, and it was assumed it wouldn't be useful because it became much more difficult to sort of calculate at that just complexity. It was just long computation times. But you could see what you have on the right here. This is a graph that summarizes sort of the performance of different teams each year. So you can see in the 2011 row, most teams were at like 25 to 35%. One guy was way out there at 50. You want to be low. Lower means better because this is an error rate. In 2012, AlexNet just kind of killed the competition. It was over 10% lower, and it was one of the first ones to go below 20% error. And since then, each year, teams have sort of refined this technique, and they've got the performance down to only a few percent error rate. What this means is, at least on this competition, we now have superhuman accuracy. How is that possible? Machine learning networks the CNN, that stands for convolutional neural network, they're actually able to pick up on things that humans aren't. This is only tangentially related, but there was actually one neural network I heard about where it was somehow able to differentiate whether a subject was male or female just looking at the iris of their eye. And humans still don't know how it's doing that. So they pick up on things that humans might not be able to do. ML is also incredibly good now at image recognition classification, so that's actually what the ImageNet task was, but also object detection, sort of finding objects in images. Image segmentation, that one is really state-of-the-art, and I just have to take one break here because I want to show you guys another video. So this is real-time image segmentation of giraffes, and you can see this is a model that also just came out this year. I think actually the paper was late last year. It's called YOLACT Plus. It stands for you only look at coefficients twice or something. No, I'm not exactly sure the acronym, but you can see it really does a good job at segmenting the animals. So here we have 2 giraffes, and it segments them more or less perfectly. So that's another one we're doing great at. This is good for a whole bunch of applications, like also when you're doing surgery and whatnot. You want to segment your patients pretty well when you're imaging them. Okay. Anything with faces we can also do great at. We do exceptionally well in these. Pose estimation is sort of when you fit a wireframe to a human's body as they move. This is super useful for video games, and we're great at it. Text transcription too. You take a picture of text, you can digitize it very efficiently. So all of these now we can do at human or superhuman levels, and they can all be done in real time. The segmentation example was 30 frames per second. So the question kind of arises, like, where do we go now? Sort of what's the next step as humans? What can we do next that's cool? And I think the answer, at least anyone in the domain, is really obvious. The endpoint that we visualize, the big trophy, sort of the magnum opus, would be self-driving cars. The thing about self-driving cars is that sorry, I forgot one slide. So self-driving cars, actually, I forgot to say that they already exist in some very controlled situations. You do see them on campuses. They're used sort of, I think some airports now have self-driving shuttles. As long as you have this pre-planned and fixed routes, they work very well. And when the deep learning revolution came around in 2012, everyone kind of felt that self-driving cars were very close. We were almost there. And now I get to the slide I was going to talk about. So I was going to say the thing about self-driving cars is that there are so many complicated edge cases. And you don't know what to expect unless you actually test one and start driving around. To give you some ideas, on the bottom left is this double sort of detour where each one of them includes text that need to be understood and contextualized. The middle bottom, you have an ambulance, and a self-driving car needs to understand that there are situations where I can break the rules, and those are based on certain sounds. In the top middle, we have a billboard in which it has a stop sign on the billboard. So can you imagine going down a highway at 120, 130, and then thinking this is a stop sign and just the car slams on its brake? It needs to understand that this is a billboard and not actually a stop sign. Top right, we have an instance where a self-driving car has thought that this is a bicycle, also problematic. And my personal favorite on the bottom right is a stop sign where someone has put go into the snow. So the issue is that when we look at these, we actually have to call back on our human experience. When we drive, we need to sort of know what it means to be human and contextualize what we've learned over the course of our existence to solve these problems, and we do it very well. If you don't do that, and if you're unable to do that as either a human driver or as a self-driving driver, you will probably die. So this is also an issue. You can't just send people out and train cars on edge cases and lose a whole bunch of people in the process. People generally shouldn't die when you're training neural networks. So I'm going to get back to that soon. I'm going to just use this as a transition to the final topic I'd like to talk about before we get to the tips section. So the last topic is artificial general intelligence. It's also called AGI. And this is sort of the creme de la creme of machine learning and AI. It's really what it means to think like a human. So to jump into this, AI, we can get it good at any task where we can define what it means to have a good action at a step. To give you an example of that, when we're training a machine learning network to be able to better identify photos or videos, it can go through the data and it can say, how did I do? Oh, I identified, let's say, 60% right that time. Then it goes through again, okay, I got to 61%. What I did there was probably a good move. I should try and keep doing whatever I did. And vice versa. If I went from 60 to 59, what I did probably wasn't good. Okay, I'll adjust my strategy. AI can still do well if we define what it means to do well in the long run. This is called reinforcement learning. Two examples of this are AlphaGo. AlphaGo is this sort of Go playing robot that defeated Lee Sedol in 2016, I think I mentioned. And AlphaGo, when you're playing a Go game, it's not immediately clear what is a good move in a situation. However, when you win lots of games, you start realizing, okay, yeah, it worked. I mean, whatever I changed there, I'm winning more games. The same idea was used for this this hide-and-go-seek simulator, in which the blue guys are trying to hide and the red guys are trying to find them. This is an OpenAI project. And if the blue guys notice they're winning more games, they keep changing their strategies accordingly. You should watch this if you have the chance, because what happens is first they start moving the boxes into place. Then the red guys realize they can use the ramp and get over. Then the blue guys realize that they can bring the ramp into the confine first and then block the doors. And then the red guys notice that they can actually exploit glitches in the code that the developers didn't know about to get in and find the blue guys. It's quite wild. So reinforcement learning also works. But when it comes to AGI, the issue is that it's extremely difficult to define what it means to do well in either the short or long term. You can't just say to someone, okay, or a robot, try and live a life for 60, 70 years and we'll evaluate how well you did as a human. It's extremely difficult. And the current approach of just making networks deeper and deeper and deeper, it doesn't seem to be enough to achieve AGI. What I mean by that is if you take an NLP model and you just push it so it's extremely deep, it gets very good at thinking, okay, which word here would be the best? Which word would sound the most human-like? It can do that. If you take a deep CNN and you just push it deeper, it gets good at thinking, okay, which objects are in this picture? However, it doesn't grasp the bigger picture. That means the larger context. As an example of this, if a robot with extremely good CNN capabilities looks up and sees a piano, the robot can instantly and very confidently say, hey, that's a piano, but it will not understand the context of, hey, there's a piano above me, this is probably not a good situation. Having that human intuition, the same thing we need for self-driving cars, is difficult, and just deepening doesn't seem to work. How do we even define true AGI is a good question perhaps to start with. There's a whole bunch of tests. Wikipedia actually has a list of them. I just chose my favorite. I love this coffee test. So this is Steve Wozniak. He was one of sort of the early guys in Apple. So he said, well, if a robot can walk into a house for the first time and makes a cup of coffee, that's probably a good sign that we're getting somewhere. That's probably pretty good AGI. The robot wouldn't know anything about what coffee is. He might have to ask some questions. He might have to figure out how to use the coffee grinder. But if he's able to do that from nothing in a house he hasn't seen before, that's pretty good. How far are we from passing this test? The sad reality is I'm not in a position to comment. I don't work on these very, very deep artificial intelligence applications, so I can't really say anything with confidence here, and I think it's important to acknowledge that. However, I won't leave you sort of empty-handed. I can give you a list of things that will define when we get to this. Things that will really determine when we arrive at this. One is quantum computers. Those will definitely be a game changer. Although again, because I'm not a quantum computer specialist, I can't say exactly when they're coming or how much of an impact they'll have. Industry adoption is another huge thing that affects how fast artificial intelligence moves. When industries are able to say, hey, this is useful, and get them in and pump money into these things, that's great. It's one of the reasons NLP is moving so fast. Government initiative is another one. The EU AI white paper was excellent. It's really helped sort of set the stage for good AI research. And also another one is how quickly can we get developing countries on board with ML research. I'll talk about this more at the end, but the idea is if we sort of are able to solve problems in these countries and they don't have to deal with where to get food or where to get clean water, but they can instead invest themselves, we unlock a huge potential in the rest of the world. And the last one, which I will comment a little more about, we need biological inspiration. There's a bit of a sad reality between neuroscientists and AI developers where, for some reason, there's just not much communication between them. To sort of compound this fact, out of the 500 accepted papers at the conference I mentioned, ICLR, only 2 were about biologically inspired architectures, so pretty paltry. This is probably not the case always. I'm sure there are some AI people out there that do have contact with the neuroscience world. But when you think about it, the 2 domains are striving towards the same thing. even if one is trying to understand them from sort of a humanistic and sort of more gray matter point of view, and the other one wants to build them in circuits, the two domains are going for the same goal, and there needs to be more communication. I'll add one caveat, which is that there isn't a reason to believe that the human brain is necessarily the optimal model for general intelligence. In fact, if you watch politics these days, there's maybe some evidence otherwise. Evolution doesn't necessarily favor what's optimal. It favors what works. It's why we have appendices, and some people can still move their ears. But it's the best thing we've got. We don't have anything better to work on. So I really think it's worth jumping into neuroscience and trying to take some insight from their papers. I've sort of grabbed 3 points here, and if there's anyone here that does do AI or just generally machine learning, these might be interesting for you. So neurons in our mind, they generally don't switch from inhibiting signals and excitation signals. They sort of stay in one or the other. In neural networks, this generally isn't the case. We generally allow neural networks to have negative or positive weights, and they're allowed to switch between them. Neurons can also have cyclic connections, which don't usually exist in artificial neural networks. This is when a neuron actually activates itself, and that's called an autopse, and we don't usually see that in ANN. A biological neuron, also this is really interesting, this just came out, it's like a month or two old. It turns out a single neuron, a single biological neuron, can actually compute very, very basic functions. One example is the XOR function, where if it receives one input from one neuron or the other neuron, it fires, but if it receives it from neither or both, it doesn't fire. To have similar behavior with an artificial neural network, you need at least 2 layers. So it sort of shows us perhaps our definition of neurons is a little off. I'd like to get back to self-driving cars now and just sort of talk to you a little more about what it's looking like. So because artificial general intelligence is probably a fair ways away, a number of companies are just trying to collect edge cases. They have cars driving around, and they're just trying to collect all the surprising cases we didn't think of. If it is indeed possible to push down the number of unknown surprise edge case encounters, we may have self-driving cars fairly soon, but it's difficult to say. There was one bit of advancement in the last month. This was just published last month. There was a sort of a convention for how to define when an autonomous car is safe. It's called UL 4600, and it's trying to set up, okay, where should we say if this is the frequency of these unknown surprise edge cases, when should we certify cars on the road? So this is a big step that now industry is starting to get ready for this and bracing for it a little. But we don't know. We don't know if this is going to be enough, or if we're really going to have to wait until we have artificial general intelligence to have self-driving cars. Okay, so congratulations everyone. That's it for the technical stuff. You survived. Now I'm going to delve into some tips. These are going to be first for people who are trying to get into the domain as a profession. Then we're going to talk to business people, and lastly we'll talk to machine learning experts and also futurists. So for people trying to get into this as sort of a job, where do you start is the first question. I really think that the Coursera deep learning and machine learning course is probably one of the best. It's the one that sort of got me started back when I was finishing up my studies. He's really, really good at explaining things, Andrew Ng. And on top of that, he also you can see his passion. He also explains things great, and he also doesn't assume any pre-knowledge. So even if you don't know coding and you don't know calculus or algebra, you can still do this. It's great. You can get all the way up to sort of some complex deep learning topics. The course is entirely free. If you want the certificate or some of the exercises, you do need to pay. But the fact that this free resource is available, it's great. There are definitely others too that I'm leaving out, but this is sort of the one I wanted to go for. For technologies, okay, sorry, I had one other thing to say. So where to go next? Another thing I wanted to mention, and this is sort of a personal observation. So I've done a lot of hiring fairs, and we just have this constant stream of people coming to our booth who are freshly graduated, and they say, I'm recently graduated, I've done some courses in ML AI, and I'm generally interested in the field. And for me, that describes probably like 10% of the population. You know, so many people have this mentality. If you really want to impress people at hiring fairs, what sounds much better is I've implemented a number of ML AI projects, such as, and then you talk about them. How do you do this? Well, first make a GitHub, then download some other people's codes. Everything is there and freely available. Try and first get them to run on your computer, then make them do something interesting, post it back to GitHub, and then credit the creator, obviously. And then after that, you'll do much, much better at job fairs. To give you sort of a first step here, I included a link and a walkthrough for using GANs. go ahead, use them, try and make them do cool things, and you're good to go. So now we get to technologies. This is really difficult because there are honestly a billion technologies, and these are just some of the ones that I've used and I've quite liked. So for ML stuff, the ones I quite like, so scikit-learn, Keras, TensorFlow, and PyTorch, those are the ones I've used a little of, I quite like, some more than others. There's also other ones like Tiano and Cafe, blah, blah, blah. Cloud stuff. Databricks, we made a partnership with them just last year, and I've really liked their interface. It's clean, it's easy to use, it runs what I need. It sort of gives you a great sandbox for more complex machine learning things, as opposed to focusing on these sort of pre-packaged ones like other cloud services have. They also recently added in this ML flow capability, which registers your model as you train, and I like it. It's sort of the one that has appealed to me the most. There's also definitely Google Cloud Platform. AWS SageMaker is another good one, also some pre-packaged stuff in there, maybe more for industry people. Azure too has ML capabilities. And also one little bit of advice, definitely for people coming out of like physics or a scientific background like me, out of academia, Apache Spark is huge, and I'd honestly never heard about it before I finished my studies and got into industry. I don't know why. It's something that we really don't use, at least not in physics, and then I see it everywhere now. It's not hard to learn, especially if you know some code, if you know Python. Definitely get a little bit of knowledge in this area because it's really, really a big thing. They also, Apache also offers MXNet, which gives machine learning capabilities. So final tips, this is the final tips for people who want to get into the industry. LinkedIn is good, follow a bunch of people who are doing ML AI stuff. A lot of what I've shown here I've learned because people just post papers and I'm like, oh cool, look at that. Another thing is the workshops and webinars, there's lots of free ones like this one, you're doing great if you're already in this one. And also another bit of just really, I guess just encouraging advice is that machine learning is really young. There are very few people who have been doing it for more than 5 years, and even fewer who've been doing it for more than 10 years. Don't feel like you're sort of a small fish in a big ocean, like I sort of started with. You're a small fish in an ocean that has a lot of other small fish. So when you approach a company, be honest about what you don't know, don't lie to them, but also don't underestimate how much you actually do know. If you have implemented that GANs and made it work, that's amazing. That's already better than a lot of applicants have done. If you're able to repurpose it and get it to do some cool new stuff, that's amazing. So feel good about yourselves. So that being said, business people are next. For business people, I don't have as much wisdom, but this is sort of a summary of points we've talked about here. When you prepare your use cases, one thing is really keep in mind this edge device future. We are going to move to this situation where a lot of data will be on these edge locations. It's both a good thing and a bad thing. Be very mindful of the GDPR. Keep in mind that statistic that so many use cases, they're just immediately devastated because of these GDPR compliance issues. A good way around this is go in very early on with someone who knows GDPR and just do a very, very quick, maybe 2-week pre-POC. Say, we're going to look at the data, let's see if we can really do this, and then advance. Don't dump huge amounts of money only to run up against GDPR or other compliance issues. Another thing, be cautious of companies that offer this non-ML AI. Again, there's nothing wrong with them per se, but you know, all that glitters is not gold. And if you really want to showcase things and improve your company image, a lot of non-ML AI solutions have great ML AI solution counterparts. And oftentimes it's just nicer to look into those. When it comes to real AI chatbots, they're probably coming soon, like I said. Prepare yourself and also get ready. Make the investment in that. That's a real bit of technology that really is working, and it's great. And also, this is huge bias because I'm an academic background person, but also involve us. Involve people like me. When I get pulled into a call with a company that wants to do ML, I love it. I can sort of say, okay, this is realistic, this isn't, this is being done, this isn't, and sort of give a bit of guidance here. So basically employ more astrophysicists and give us jobs because we do a good job. And the last tip for business people, don't be afraid of ML. One of the machine learning conferences I was at, the guy got on stage and he said the biggest hindrance is because of fear. Companies are just scared. They say, we've always been doing things the way we are. When you implement ML, not only does it improve your image, and not only is it the best solutions these days, but also it pushes sort of human development. The more companies get on board, the better it is. And maybe take a course yourself. The Coursera one I showed you, it can be done in a month, at least the basic machine learning one. It's not at all overly technical, and you'll really feel more comfortable making decisions about use cases when you understand the technologies. When it comes to ML experts, I have definitely less to say. One thing I would say is look to neuroscience for inspiration. Outreach is great. Try and do it whenever you can. And also, I'd love some feedback. I'm sure, again, I made some mistakes here. So definitely send me a message, hit me up on LinkedIn, and say, hey, by the way, this is actually outdated, or this is actually a new way of doing this. That would be awesome. So the very, very last thing, I have a few closing remarks, and then we'll open it up to questions. The first one is for the futurists. So if you're curious about where the future will take us, right now, it seems that we have human-level conversation ability. That seems to be checked. It seems when it comes to photo and video, we're rocking it. They're indistinguishable now, more or less. Human-level computer vision tasks also, like I showed, we're kicking ass. Really, we can do more or less everything we need to besides self-driving cars. Self-driving cars, it's hard to say. In the next decade, if we can show that this unknown edge case encounter thing can be minimized, and you're only sort of running into these unknown edge cases once every few, maybe like hundreds of thousands or millions of kilometers, it might be possible in the next decade. Unfortunately, there's a real risk that this isn't the case, and it'd be nice sort of to learn a little more from where the situation is at by talking to self-driving car people. But if not, we might have to wait for something closer to AGI. Maybe not full AGI, but a little closer to it, where it can start contextualizing systems. If this is the case, probably a few decades, unfortunately. When it comes to real AGI, so that's sort of being able to have a human that can do human-like things, I'm not sure about the robotics side. I'm not sure about how far along we are with things like these amazing like Boston robotics videos where the robots sort of jump over bricks and do backflips. I'm not sure how close we are there. But from the actual human mind side, I think in the next century would be my guess. We should be able to get to something where realistically it's on the level of cognition of an adult human. I think that's realistic. I put 2 question marks because I'm definitely, not, again, an AGI person. I'm not sure exactly how far we are along, but I think probably not within our lifetime, unfortunately, but maybe the next one. If you believe in reincarnation, you'll get to see it. Superhuman intelligence, that's going to be awesome. This is a point where our definition of humanity and what it means to live in this existence will be vastly different, probably a couple centuries. I think getting to human level will be a big push, and getting past it probably won't be too much effort, seeing as we've shown that CNNs can already get superhuman on a lot of tasks. If you can just incorporate it with a human brain, in a way you already have superhuman capabilities. So I'd say probably the next couple centuries. Okay, so now the final question I want to ask is, what's the best way to advance AI? If you're curious about this domain and you want to do it, you might say, okay, well, I should independently engage in AI research, and that's great. That really helps the domain. But if you truly want to make a difference and push AI towards the future, whatever that is, you should be encouraging developing nations to do this stuff too. This is something I've been trying to push forward recently. I've been in contact with the University of Gambia, and I gave them a call in January. I got in touch with them and I said, hey, I am a machine learning person. Do you want to learn about machine learning? And the dean got in touch with me and he was super, super thrilled. He's like, yeah, we'll pick you up at the airport, man. It's going to be awesome. So this is really, really encouraging. Surprisingly, for some of us, I didn't expect this, but they have pretty good facilities in the Gambia. They have excellent computer labs. Their computers are running the most recent versions of Windows and Ubuntu. Wi-Fi is decently good. And with that being said, the thing they're lacking is there's a bit of this disconnect between African universities and universities in developing countries and AI research in Europe and North America and East Asia and all this. So if we really want to push forward, we need to get these people on board. This makes much more of a difference. You can only do so much as one AI researcher, but if you go and inspire 50 AI researchers, you can do as much as 51 AI researchers. So it's just numbers. What's the idea here? I'd like to encourage more international academics and industrialists to try and go into African countries and really, really push them to get on board with this AI. ML technologies can also be amazingly beneficial for these countries. With ML, we can do things like resource management. I put patient treatment optimization here, which I showed is possible with Edge TPU. Flood prediction is another one. Predictive maintenance. These are problems that a lot of these countries could really, really, improve if they just had the technologies. Getting these countries on board, it's great. We should do it. So this is really unorganized, this idea of Africa AI. What we have now is we have this AI group coordinated with some people in Gambia. It's called Gambi AI. I know it's not a great pun, but I thought it was cute. And we actually have some people from Gambia, from the University of Gambia in this call right now. So we're testing sort of what it's going to be like, what the quality is like. If it's good, maybe we could try and get more people doing workshops directly catered for the interests of University of Gambia. So the game plan is this. I was actually supposed to take a flight to the Gambia on Friday. I had my flight Friday at 7 p.m. I was going to fly to Senegal and then take a bus to Gambia. That's canceled because of COVID. Really a bummer. We were going to do like a week-long, 3-day ML workshop. But like I said, they're in this webinar. We have some people there. And if the signal strength is good, that would be awesome. We could maybe do it remotely. Although I would still really like to encourage some people in Europe to go down. The flight costs about 350 euros from Europe round trip, at least from Munich. Go down there, talk to them, get them inspired. This is not at all funded. They can pick you up at the airport and they might be able to help you with accommodation. But what a cool thing. If you're looking for something to do in life, this is awesome. So I really hope some of you contact me and we can get you into this system. That's it. I hope you've survived. I think, we did pretty well. 1 hour and 4 minutes, so just about an hour. I want to give a huge shout out to Alicia. This woman has been invaluable. She's put together all these great conferences, these webinars every week. And just to summarize our schedule for the next few weeks, Wednesday the 20th, that's next Wednesday, we're going to take a break from these weekly webinars because the 21st is a holiday, so everyone will be going out to get drunk. On the 27th, we have Adriana, who's going to be giving one on Databricks projects, so how to sort of get Databricks things running online. There'll also be some cool stuff about deep learning too. And the talk will be in German. I think it's our first sort of German Wednesday webinar. On June 3rd, potentially we'll be having a joint webinar with AWS. This is sort of still in the works, but Socrates would be running that. So that's it. Congratulations for making it to the end again. This is me. You can find me on LinkedIn. You can also find me on GitHub. Feel free to download my code and turn it into killer robots. So let's open up to questions. Let me just drink some water first. My mouth is a little dry. Hold on 1 second. Okay, so we have 2 questions here. Also, you guys feel free to write anything you want. One person said your voice is echoing. Oh, I hope that changed in the last while. Someone else said, please give a couple examples for a possible point in ML but not AI in your Venn diagram. Okay, so if you go back to my Venn diagram, let me just pull it up. It's here. So, if you go back to my, this section here, this green section, you're right. There's not too much in it, and again, it's a bit of a divide. Some people might say all machine learning is artificial intelligence. I personally feel there are some things that aren't artificial intelligence in ML. One example I gave here is curve fitting. Some people might sort of disagree with me here, but curve fitting is just something like so basic. It's been around for a long time. I think saying that is artificial intelligence is maybe pushing the envelope a little. Other than that, maybe some very basic applications in like trend fitting, I would say, are ML and not AI. But again, like I said at the beginning of this slide, this is sort of my personal definition. I'm just including it here to give a bit of a heuristic for business people who want to do this stuff or sort of want to understand where the buzzword stands. You're definitely in the right if you want to include everything as AI, like all ML is AI. Okay, who or what will be driving the shift to storing training data at edge locations? That's a really good question. I don't have a great answer. This is stuff that I've taken out of conferences and read online. The EU article, the EU white paper is publicly available. You could sort of go and look into what they're saying there. My hunch would be that they'll just see that the capabilities, sort of companies in general, will start seeing that the capabilities are better if they put their models on these devices. Another thing that might do it is just GDPR might kind of force it. A lot of sort of the use cases I've been talking about are ones where now you'd really run into a lot of AI. We've seen things like trying to train models on big corpuses of handwritten letters, and we hit a wall right away with GDPR. So the real way to do it might be to try and have a GANs that generates these artificial documents, and then after that, they can just sort of push the documents, the models rather, onto these small legal firms or whatever, and then they can be updated on their personal stuff. So I think that probably summarizes that. Also before I keep answering questions, let me see polls. So what's your primary interest in the webinar? Let's see where people were coming from. So good, not too many people were forced. A lot of people who want to get into ML and AI professionally, which I'm happy to see, because that's sort of one of the main slants I put into this presentation. No one in business, which surprises me. We actually had quite a few people from businesses who I think signed up, so I guess money making wasn't as big a thing as I expected. Cool, guys, cool. It's kind of neat to see where you're coming from. And also, yeah, not surprisingly, not too many people for the more ML experts, which is again a sign that this is a young young thing. Okay, so what do we have here? We have new to ML AI recommendations on the courses I can do in ML as a beginner. Okay, great. So actually, this is I believe this is Eob, who is one of the people contacting from University of the Gambia. So really awesome that we have you here. Let's see, what can you do? So the best one I would say, again, is the machine learning and deep learning courses on Coursera. They're excellent. Another one I really like is sort of 3 blue, 1 brown. I can message that to you later. He's one of this YouTuber, and he does these great videos explaining artificial neural networks and these deep neural networks. He's excellent. You can check his out. And then besides that, Khan Academy, of course, has a bunch of good ones. Really, any sort of online platform offers good ones. And hopefully for you, we'll also have some machine learning workshops in Gambia soon. I'm going to wrap this up. It's been really fun. Again, this is a domain I'm super, super into, and it's been really a pleasure to talk about this. I really appreciate you guys all coming out. And yeah, that's it. So have a great end of week and weekend, and take care and keep washing your hands. And take over the world with killer robots. Bye-bye.